Good evening, students. 9th standard science. Today's topic is solution. In solution, already we studied the topic about that solution. What is solution? What is solute? And then solvent. What are the different kinds of solution like that? Okay. So I think I gave one activity to you. Anyone can complete that? Have you all referred that related concept? I gave one task to you. What are the examples of binary and ternary solution? Think. Is that right? Did you refer the topic? Did you search that answer for that questions? Please reply. Yes, very good. Yeah, show me. Yeah, put an emoji. Okay, fine. Yes, one center student, their hand, they search the answer for the questions. Okay, fine. Please do what are the details your teachers are in this institution. You please just you go and refer the answer for the questions. That's why only we can recall that details about the concept of that sessions. Okay. So what is solution? A solution is a homogeneous mixer. Okay. What is solution means? It is a homogeneous mixture of that. It is a homogeneous mixture. More substance. This is the definition of that solution. Okay. So in that solution, there are two kinds of components. One is solute and then another one is solvent. Solute and then solvent. Okay. Lesser quantity component is called as solute. Lesser quantity component is called as solute, and then higher quantity of that component is called as solvent. So this is the basic details about that solution. What is solution means? Solute plus solvent. How the solution is? Form means solute and then solvent. So these two components to join to form a solution. Okay. Solute plus solvent. We will get the solution. So based on in last session we learned different kinds of solution depends upon the quantity of solute and solvent like that. But today's session we are going to classify that solution depends upon the particle size. Okay, based on the particle size of the solute, the solution are divided into three types. Depends upon the particle size of the solute. So there are different kinds of size of the particles are mixed in that solution. Mean how we can classify? Yes, types of solution. Which type of solution? In this category is based on the particle size. Based on the particle size, we can classify the solution into three types. What are they? One is true solution. The first solution, the first kind of solution is called as true solution. Another one is colloidal solution. So Next one is colloidal. And then third one is suspension. So, depends upon the size of the particles. Which one? Based on the particle size means solute particle. So, depends upon the solute particle size, we can classify the solution into three categories. One is true solution, second one is colloidal, and third one is suspension. Okay. So, today we are going to understand what is true solution, what are the properties having the true solution, what is colloidal, what are the properties and the example also, what is suspension, what are the qualities and the examples of the suspension solution. Okay, this is the heading of the session. So today we are going to learn about that three types of solution, that is true, colloidal, and then suspension. So first one is true solution. True solution means how we can prepare the true solution. Different kinds of solution we are using in our day-to-day life. Salt solution, and then coffee, tea, and then uh, uh, juice, and then sugar solution, like that. Okay. So, in this manner, first one, we are going to prepare the sugar solution. Sugar solution. So, in sugar solution, what are the components? There are two components are present here. One is sugar, another one is water. There are two main components are essential for the preparation of true solution. One is sugar and then water. Okay. Sugar is a lesser quantity. So, and sugar is lesser quantity, that is solute. Water is higher quantity, that is solvent. Okay. So, first one is solute, another one is solvent. So, sugar is the lesser quantity, so that is the solute of the solution. And then water is the higher quantity, so that is called as, what is that? Solvent. Okay. So, sugar is completely dissolved in water. So, when I take one small size of beaker, so see here, adding some amount of water to this beaker. Yes, put some amount of sugar also here. Yes, within few minutes, the sugar is completely dissolved in this solvent, that is water. So, when the particles are completely dissolved, just a minute. So, when the particles are completely dissolved and that solution also very clear. So, the clear solution is called as true solution. So, this is a sugar or salt solution, whatever it may be. Sugar or salt is completely dissolved into water. The solution nature is very clear also. So, in this kind of solution is called as true solution. So, the particles are completely dissolved. So, this mixture is called as true solution. So, that is the main property. Completely dissolved. Which one? Particles. So, the Sugar is completely dissolved in water. And then property, the solution also very clear. So this type of mixture is called as true solution. This is the main characteristics and the properties of that solution. Okay. First thing, that particles are completely dissolved. And then second thing, the solution is very clear. Okay. And next one, colloidal solution. Is there any doubt in a true solution? True solution means the solution particle, that is solute. Solute is completely dissolved in water. And then the solution nature also very clear. Very clear solution is called as true solution. And next one is colloidal solution. What is colloidal solution? Yes, the second category is the colloidal. So colloidal means I'm going to take starch and the solvent is water. So starch is the solute. Water is the solvent. So solute is completely dissolved or not. Now we are going to verify, because the solution is not clear nature. So I'm going to taking some amount of water, add some starch material. So this solution is, now I'm going to stir this solute. Look at the solution. How it is? Yes, it looks like a cloudy nature. How it is? It is looks like a cloudy nature. So it is not a clear. So compared to the true solution, the true solution is very clear. So see this beaker, it is very clear. So this is true solution. This solution is not clear nature. It is looks like a cloudy nature. So it is not clear. So the particles are not dissolved. Solute is not dissolved in the solvent. So it is called as colloidal solution. The solution is not clear nature. So this kind of solution is called as colloidal. So in true solution, the solute is completely dissolved. So it was very clear that solution was called as true solution. The second category is the colloidal solution. Colloidal solution means, for example, I took some amount of starch, it's the solute, and water is the solvent. The solute is not dissolved in the solvent. So it is looks like a cloudy nature. So in this kind of solution is called as colloidal solution. Okay. So next one is suspension. Next category is suspension. Third one is called as suspension. In suspension, what is the solute of the suspension is different kinds of flour, like wheat flour or rice flour, whatever it may be. So now I'm going to take some flour. Wheat flour is the solute and water is the solvent. In this solution, that is suspension category, taking some quantity water, put some flour. So look at this beaker. We're going to just, I'm stirring the solute into the solvent. Within few seconds, the particles are completely settled down the bottom of the beaker. Have you seen? Is that clear? Yes, the solution is not clear. Within a few seconds, the solute is settled down the bottom of the beaker. So this is the nature of the solute. The solute is not dissolved in water, as well as immediately means 1 or 2 minutes it was settled down the bottom of the beaker. So in this kind of solution is called as suspension. The solute is completely dissolved means that is true solution. Second one, cloudy nature was occur in that area means that is called as second one, colloidal solution. And then suspension means it look like a turbid. The fine particles are settled down the bottom of the beaker. So this kind of solution is called as suspension. So particles are not dissolved. So it is turbid nature. And next point is settle down the bottom of the beaker. So this is the correct clearance of the suspension. Solutors, wheat flour or rice flour, different kinds of flour. But that flour is not dissolved in water. It looks like a turbid nature and settle down the bottom of the beaker also. This kind of solution is called as suspension. So, what are the details we learned now? Depends upon the size of the solute particle. We classified the solution in 3 types. That is true solution, and then colloidal solution, and suspension. What is true solution? What are the example? How the true solution is formed? And next one is what is the nature of the solution also. And next one is colloidal solution. What is colloidal? And then how the nature of the colloidal solution. And third one is suspension. What is suspension? How the particles are dissolved. How it is look like a turbid nature and not dissolved in that solution. Okay. So in one more details are also in the colloidal solution. In colloidal solution is a heterogeneous mixer system consisting of the dispersed phase and the dispersion medium. The dispersion medium can be divided into 8 categories, that is solid and then solid and liquid. In this nature, the classification of the physical state of dispersed phase and then dispersion medium. Dispersed phase and the dispersion medium, we can classify the colloidal solution into 8 categories. What are they? Now I'm going to explain the 8 category of the colloidal solution. First one is, what is the category? Based on the physical state of the dispersed medium, dispersed phase and dispersion medium. So in this category, we can classify the solution into 8 kinds. What are they? First one is solid and solid. Solid and solid means what are the solid materials? The metal like that, alloys, germs, and then glass materials. So these are all the examples of the solid and solid. First one is the dispersed phase, that is solute. This is solvent. And then solute and solvent, these two are mixed to form a solution that is called as solid solution. How it is occur? It is in solid nature. So what are the examples means? Alloy. This is the example of the solid solute and solvent mixed together to form the solid solution. Example of this first category, alloy. Okay, next one is solid and liquid. Solid and then liquid nature. Solute is in solvent and then solvent is in liquid nature. So this nature is, the name is liquid. It is called as solution. Liquid solution. What are the example means? Yes, we are using ink. Yeah, so ink is the best example, and then paints. The paint also the example of solid liquid mixture. Solid mixture is called a solid solution. Examples is alloy. Next one is a solid liquid mixture. Example is liquid solution. The name of the solution is liquid, and then next one is solution, or the example is ink, and then paint. Next one, solid and gas. There are three states. Said there are three states. So first one is solid and then gas. Solute is in solid. Solvent is in gas nature. The name of this mixture is called as aerosol. The name of the mixture is called as aerosol. So example is smoke. Smoke is very good example of solid and gas mixture. Aerosol name. That smoke is the good example of solid gas mixture. And then next one is liquid. This is the fourth category. Fourth, liquid and then solid. Solute is in liquid nature and then solvent is in solid nature. It is the formation of gel. Gel is the name of that mixture. So we are using day-to-day life curd, cheese. So these are all the example of liquid and solid nature. Liquid solid mixture, curd and cheese, and then liquid and liquid mixture. In this mixture is called as emulsion. So emulsion name means liquid and liquid nature. And then milk. This is the example, milk and the butter. So this is the good example of the liquid mixture. And next, sixth one, liquid and gas. So liquid gas means this is also called as aerosol. And the example is the very good part one, mist. So mist is the good example of liquid gas mixture. And then seventh category, gas and solid. Gas and solid mixture is called as solid foam. Solid foam nature. What is the example means? Cake, bread. These are all the examples of gas and solid mixture. And next one is last one, gas and the liquid. So gas and liquid means foam. Foam is the form of gas and liquid mixture. Soap, leather. So this is the example for gas and liquid mixture. So these are all the 8 categories of the colloidal solution in the physical states of dispersed phase and the dispersion medium. Okay, so now we are going to see the simulation. One second. From the help of this simulation, we learned the clear details about that. See, what are the solution? We studied, yes, there are 3 kinds of solution. True solution, suspension, and then colloids. Okay, yeah, there are 3 categories of the types of the solution based on the solute particle size. Is that clear? Yes, there are different kinds of properties are here. Transparency, filtration, stability, and Tyndall effect. With these, the help of the categories, that is the properties, we are going to understand what is true solution, what is colloid, and then suspension. First, I am going to choose the transparency property and choose true solution. So, this is the cellophane paper. Just I'm going to show the paper behind the solution. There are 3 test tube, A, B, and then C. How is the nature of that result, pa? Yes, the paper is clearly visible. Yes, we can able to see the paper in clear nature. So, this is the true solution. So, these 3 test tubes are in true solution. Look at the answer. True solution are transparent nature. This is the first property of the solution, that is true solution category. In transparency, the 3 solution are very clear solution. It is in transparent nature. So, it is confirmed these are all true solutions. Next category is filtration. So, there are 3 test tubes. 3 test tubes are having in different kinds of solution. One is sugar solution, another one is salt solution, and another one is alum. So, this is the stand, and 1 test tubes are here, and funnel and stirrer also. Now, I am going to transfer the sugar solution into the beaker. Look at here, this filter paper. What is that? There is no solid particles are appear. So it is not solid particles. It is the clear paper in wet nature only. So see the answer. Solid particles cannot be separated from the true solution. So first test tube solution is confirmed. This is the true solution. Okay. Next I am going to taking the second one, that is the salt solution. This solution also filtered. Look at this paper. There is no solid particles in salt solution. There is no solid particles in the filter paper. So, the B test tube solution also confirmed this is true solution. And next one, I'm choosing the third test tube, that is contain the alum water. So, look at the filter paper. There is no solid particles. So, these 3, third one, the alum water also a true solution. So, this is the second confirmation of the true solution. And third property is the stability. Now I'm going to, there are three types of solution: sugar, salt, and alum water. And then one machine also. Now when I on that start button, yes, it is moving. With the help of the machine, we are going to understand the stability of the solution. So, it is in clear nature that particles are not settled under the test tube. So, the answer, true solution are stable, do not show the deposition. So, there is no deposition in the test tube. So, this is the third confirmation test of the true solution. And next one is the Tyndall effect. It is the one of the important property for the confirmation of true or colloidal, like that. When we pass the light in this solution, means I'm going to three kinds of test tube solution. First solution I am taking and holding to that holder. Thus I pass the light. So what are the clearance of this? Yes. Is there any identification? Is there any? The light is passed through that solution. Okay. So, yeah, what is the confirmation of this nature? The Tyndall effect means when the light is focused into the solution, path of the beam become visible or not. It's not visible. So, this is the true solution. So, the true solution confirmation is that light is passed through the test tube, means is that visible or not? And then second one, salt solution, the same kind. So, it is also the true solution. Third one, alum. Just the light is passed through that alum water. Is also not visible within the test tube. So, these three test tubes are contain the true solution only. So, true solution nature is clearly understand with the help of that part. Okay. Next one, I am going to choose the suspension. First property is transparency. The same thing, the cellophane paper behind the test tube. So it is an opaque nature. The paper is not visible. So this is the suspension. A suspension is opaque. It is not visible. The paper is not visible. So this is the suspensions. And next one is filtration. So first one is soil and water. Second one is chalk powder and water. Third one is sand and water. So there are different kinds of sand, soil, sand like that. Black soil, red soil like that. So I'm taking the soil solution. The solution is filtered with the help of the funnel and the filter paper. Yes, the solid particles are filtered above that filter paper. The liquid nature only come out that funnels. The solid particles are filtered. So, this is the suspension. Suspended compounds of the suspension can be separated in the filtration. Next one is, yes, chalk powder also settled on the filter paper. So, this is the suspension. And third one, sand and water. I'm going to filter the sand solution. The sand particles are settled down in the filter paper. So, these are all the suspension. So, the suspension property is confirmed. And next one is stability. Stability. Yes. See here. Yes, very clear. The soil and then chalk powder and sand particles are settled down the bottom of the test tube. So, it is the suspension material only. So these three solution, soil, chalk powder, and then sand. So that particles are immediately settled down. So it is the suspension matter. And next one is Tyndall effect. First I am choosing the soil. Look at here. What is going on? The light is passed through that. What is that? Diffusion particles. How it is? Suspension, colloidal, and then true solution means the Tyndall effect, the scattering of light. Scattering of the light means the light is passed through. It is not an clear. So this is the suspension. See here also, the light is not visible nature. So, this is the Tyndall effect and then it's confirmed. So, it is the suspension solution. Third one, sand and water. The light is passed through, it is not invisible. So, these solution are the suspension. Okay. So, next one is colloid. Colloid is only two test tubes. One is starch, another one is egg albumin. So first property is transparency. Here it is also opaque medium only. So it is not called as opaque, not invisible. So not transparent, not opaque. It is called as translucent. Translucent means it is not clear, not clear nature, not in opaque nature means this nature is called as translucent nature. Translucent nature is appear means that kind of solution is called as colloid. And next property is filtration. What is going on? The first starch solution is filtered with the help of the filter paper component causing the colloid cannot be separated. The filtration, the same kind of solution only come out. Okay. Second one, egg albumin solution. Going to filter, see the filter paper, there is no solid particle. So this is colloid. So the second property is confirmed. Next one is stability. See here, there is no changes in this area. The particles are not settled down. So this is the colloid. Colloids are stable. The solute particles do not settle down. So this is the colloid solution. Next, last one is Tyndall effect. Look at here. See here, yes, one bright light, white color is visible in this area. So Tyndall effect is observed in the colloidal solution. So the light is focused to the colloid solution. The path of the beam becomes visible in this area. So this is confirmed colloid. So Tyndall effect is illuminated path. So this is the correct formation of that colloid. Okay. Second one, egg albumin. See here, the light is clearly visible. So, colloid is confirmed with the help of the Tyndall effect. Tyndall effect is occur in this area. The beam. So, this is colloid nature. So, students, is there any doubt regarding the true, colloidal and the suspension? With the help of these three properties, so we can clearly observe what are the properties of that three kind of solution, what is that nature also. Okay, is that clear? Shall we move to the next category? Okay, next one is emulsion. Next, another one more topic is emulsion. What is emulsion? Emulsion means, so the emulsion is the colloidal or two or more immiscible liquid dispersed in the another liquid. Two liquids, that is one type of liquid particle is two types of liquid particles are mixed to form one solution means that is called as emulsion. So the one type of liquid particles get scattered to the another liquid. Okay, emulsion is the special type of mixture combining the two liquids. Okay, yeah. So combine two liquid particles to form that one solution means that is called as emulsion. Okay, so what are the examples of the emulsion means liquid, that is milk, butter, cream. So these are all the examples of emulsion category. What are the type of the emulsion? Two liquids are mixed can form different kinds of emulsions. So what are they? Oil and water. Oil and water mixture. How they are mixed, ma? Oil and water means, yes. Have you all see that road in rainy season? Yes, different kinds of colors are visible in that area. So some one or two vehicles are leak some petrol or diesel. The area is in wet condition means definitely the oils are come out from the tank. The petrol or diesel are come out from that bottles. Already rainy season means the water and as well as the petrol was mixed in that area. We can observe different kinds of color in that place. The oil is not mixed into the water, so it was float on that area, so we can visible the different colors in that place. That is the best example of the emulsion part. So the oil droplets are dispersed in water means they are floating in that place. It is not mixed into the water. So this is the good example of the emulsion. So the true solution, what are true solution, what is colloid solution, and then what is suspension. So this concept is over. Next we are going to move the another topic is compound and mixture. What is compound and mixture? Compound and mixture. This is the next heading of your syllabus. So, what is compound? There are one or two more elements combined to form a new substance. Two elements combined to form a substance. So, that is called as compound. What is compound? There are two elements are joined together to form a compound. So that new substance is called as compound. For example, water. Water. What is the formula of water? H2O. Hydrogen and oxygen join together to form one substance, that is two part of hydrogen and one part of oxygen to combine water molecule, carbon dioxide. Carbon and oxygen, these two elements join together to form carbon dioxide, one part of carbon and two part of oxygen to form carbon dioxide. So these are all the examples of compounds. So this is compound, two part of hydrogen and then one part of oxygen. So this is the example of carbon dioxide. So Next one, water molecule. This is the example of carbon dioxide. One carbon and two oxygen. So this is the example of compound nature. So one is water, two part of hydrogen and one part of oxygen. So water is formed with the help of hydrogen and oxygen. Carbon dioxide is formed with the help of carbon and oxygen. So this is the examples of compound. So what is compound? Compound means two or more elements combined chemically form a new substance. So another one example is sugar. Normal sugar, C12, H22, O11. This is the formula of sugar. Carbon, hydrogen, and oxygen. Three elements are joined to form the normal sugar. So, it is also the very good example of the compound. And one more example, sodium chloride, NaCl. Sodium and sodium chloride compound. So this is also the example of it is our normal salt. We are using cooking purpose. It is the best example. Sodium is the metal, and then chlorine is a non-metal. These two are joined to form a compound, that is sodium chloride. So this is the explanation about the compound. Okay. Next one is mixture. Next one is mixture. What is mixture? A mixture is an impure substance. The proportion is not clear. It contains two more kinds of elements, but it is not in right proportion. That is the compounds, that is the different kinds of elements are joined to form one mixture. The element proportion is not clear. So this kind of mixture is called as, this kind of join property is called as mixture. Okay. What is mixture? Two more elements joined to form one compounds. So what are the different kinds of, for example, lemon juice. Lemon juice means we add sugar and lemon and water. Is that any right proportion to prepare lemon juice? No, there is no clear proportion to prepare a lemon juice. These kind of preparation, these kind of the solution, that called as mixture. So mixture means that impure substance, it contains some more elements or compounds are physically mixed in different ratio. Okay, in different kinds of ratio it is formed. So this is called as mixture. What is the difference between the compound and mixture? What is the difference means? What are the nature? First one is mixture. Another one is compound. So it contains two more elements, two or more. It is a compound means it is a single substance only. First thing, it is a single substance. Mixture means two or more substance. And next one is the constituent is in any proportion. The proportion is not clear. Proportion is not clear, but it is definite proportion. Definite proportion because two part of hydrogen and then one part of oxygen. So H2O, carbon dioxide. Carbon is one part, oxygen in two part. C6H22, C16 and then H22O11. These were C12, H22O11 is the good example. That is the sugar formula. So these proportions are very, very clear. Definite proportions for that compound. Mixture means there is no right proportion to prepare that matter. That is the second difference. The properties to show the constituents, but they do not show the properties of the constituents in that compound nature. So they can easily separate in physical method. Mixture. Mixture means our snacks items. And that snacks items, we can easily separate each and every particle from that. But coffee, can I take one tumbler coffee? Shall I separate the coffee powder and the milk? Never. So it's not easy to separate that components. But mixture means the components are easily to separate the materials. So these are all the examples of, difference of compound and mixture. So this is homogeneous, this is heterogeneous. Homogeneous and then heterogeneous mixture. There are two types of mixtures. One is homogeneous, another one is heterogeneous. Homogeneous means completely dissolve that material. We can't separate the components. In heterogeneous, yes, this component is easily separate that from the milk. So this is the main property of the homogeneous and then heterogeneous mixture. Homogeneous mixture means true solution and alloy. Heterogeneous mixture means suspension and then colloidal. Okay. Once again. The simulation for the compound and mixture. Yes, with the help of the simulation, we can get the clear idea about the mixture and the compound. Sir, what are the components? One is mixture, another one is compound. So what are the properties? Basis of the appearance and then behavior towards the magnet and the action with carbon disulfide, action of heat and action with dilute hydrogen chloride. First one is base of the appearance. Yes, this mixture contains Fe and S, iron and the sulfur. First, I'm going to mix that material. How it is? Wow, completely mixed. The yellow particle sulfur iron filings are clearly seen. They non-uniformly distributed throughout the mixture. So, they indicates that mixture is the iron and sulfur is the heterogeneous appearance. Okay. So next one is compound. FES. This is the compound example. There is no changes. So the uniformly gray-black particles seen throughout, so indicating that compound is FES is the homogeneous appearance. So this is the compound nature. First one is mixture. This is compound. So basis of the appearance, we can separate it. Which one is mixture? Which one is compound? And next property is behavior through the magnet. Yes, Fe and iron. First I am choosing the mixture. the magnet is near the particle. Wow, the iron particles are easily attached in the magnet. So, iron is the easy attract. The iron particles are attracted to the magnet. So, this is the mixture. Iron filings cling the magnet indicate iron has retained its the original property, that is magnetic nature. So this is the mixture. And next one is compound. No changes. The iron particles not separated from this area. So this is the compound. So there are no particles clinging to the magnet, indicating there's lots of original property, that is magnetic formation. So this is confirmed compound. Next property, action with carbon disulfide. First one is FeS mixture. Going to take some carbon disulfide into the test tube. Look at the test tube. Is there any changes here? No. Then there is no changes. No. Next one. Stir the test tube. Yes. Now I am stirring the test tube. The particles are settled down. The yellow particles of the sulfur is dissolved. Before stirring, the particles are normally, look at that test tube, that there is no changes in the test tube. After the stirring, the iron particles are settled down. So the yellow particle sulfur is completely dissolved in carbon disulfide to form a yellow solution. The particles of iron is settled the bottom of the test tube. In compound, okay. Next one, I am choosing the compound. Once again. So, carbon disulfide, I am choosing that. FeS, I am adding some carbon disulfide to the test tube. Yes, just you shake that test tube, there is no changes. So this is the compound. There is no changes. This indicates that sulfur loses its original property of the formation of compound nature. So this is the confirmation test of compound. And next one is action of heat. So I'm going to on the burner. Yes, what is going on here? Yes, the particles are evaporated from this area. The particles are evaporated in compound. The nose changes observed the compound FeS does not undergo the chemical reaction. There is no changes during the heating effect. And then next one, choosing that FeS mixture. The burner is on position. What is done here? So the color is disappear. The color is disappear. There is no yellow color in the China dish, in that area. So a black mass formation of particles, iron and sulfur cannot be seen separately. So both laws are individual properties of heating effect. So this is the confirmation of compound and mixture, and then action with dilute HCl. Going to on the burner. Just a minute. Yes, the burner is on position. The changes are going on in the test tube. This is the mixture in the test tube. Okay. Next one is compound. The burner is on. Yes. Next one is next sample. Look at here. Is there any changes? Sorry, it is not right functionings. So the second test is I'm choosing here now. The burner is an on position. Yes, the action was done here. And then I remove the test tube. Sorry, from this help of this part, we can identify that mixture and then compound. There is no changes when I just take one matchsticks and to after the confirmation test, we are going to near the matchsticks to that test tube means immediately the flame will be in off position. That is the result of this test. So when we confirm from these properties, what are they? Basis of the appearance and behavior towards the magnet, action with carbon disulfide, action of heat. With the help of these four tests, we can clearly understood what is mixture, what is compound, what are the properties also. Okay. So students, is there any doubts? Sorry, time up. What are the details we learned in the session? Type of the solution, that is true, colloidal and suspension. And then next topic is compound and mixture. What is compound? What is mixture? What are the properties? And then what is emulsion also? So please read the topics. Is there any doubts means you please, we will clarify in the next session. Is there any doubt means just you ask me now. Just put your hand. Just raise your hand. Okay, or otherwise you please read and is there any clarification? We will discuss on the next class. Okay. Thank you, students. Jai Vidya Shakti, Jai Bharat, Jai Hind.